Okay, so let's talk about factoring polynomials. Now, to understand this method that I'm going to show you, it's called the guess and check method. It's important to understand how two polynomials get multiplied together. So taking a look at these two binomials, they're binomials because they have two terms in each of them. Okay, I want to multiply these together. So the first thing I want to do is this term needs to get multiplied to each of these terms. So 2x times x is 2x squared. Then 2x times 4 is positive 8x. Then he's done. I've now multiplied him to both of these. So now I'm going to multiply this term to both of these. So negative 3 times x is minus 3x. And then finally, negative 3 times 4 is negative 12. So now I'm done multiplying those together. So now as I simplify this, it looks like I can add these two together. Those are like terms. They both have x's on them, just as x with a power of 1. So I can't combine these ones because it's x squared and this is just an x. But I can combine these. So let's see. Nothing to combine that one with. So my answer is going to be 2x squared. Positive 8 minus 3 is negative 5x minus 12. So when I multiply these two things together, I get this answer. So factoring a quadratic, this is a quadratic equation because it's a degree 2. To factor a quadratic, what I'm doing is I'm going from this right here to this right here. So it's like undoing multiplication is kind of what I'm doing. I'm trying to come up with two things that multiply together to equal this. So what I'm going to do now is, even though I've multiplied this out, I want to show you how to factor this using the guess and check method. Now my live studio audience has just told me that I made a mistake on this, and this should be a positive 5 right here, and they are absolutely correct. Oh, that was sucked. Let's try that again. There we go. So that should be a positive 5. Sorry about that. So let's see, what was I talking about? Now I forgot. We were talking about how to factor this. So here's what I'm going to do. I want to factor this guy right here. So I know that my answer is going to look like this. It's going to have two sets of parentheses, so two things being multiplied together. That's what I want my answer to look like. And this is true for everything that I factor. I want it to look like this. I'm going to have a binomial in each of these. So I'm going to have something here, something there, and something there. Okay? So the question is what goes there? And then in between those, since these are both terms, in between these is going to be either a positive sign or a negative sign. I don't know which one yet, but it's either going to be a plus or a minus sign in between each of those. So here we go. Let's figure out what numbers to put in these spots. So as we look kind of back, as we kind of work backwards here, how did I come up with this number right here? So it came from here, and it came from my first two values being multiplied together. So the question I want to ask myself is, what multiplies together to get 2x squared? So over here, kind of my little workspace, I'm going to write the number 2. And I'm going to write everything I can think of that multiplies together to get the number 2. And fortunately, there's only two options, 1 and 2. That means in these two first blank spots, I've got to have a 1x and a 2x, since 1x times 2x will get me 2x squared. Doesn't matter which one I put where, so I'm going to put 1x right here, and I'm going to put 2x right here. Okay? I now know my first two terms. Now the question is, what goes right here and right here? Well, let's look backwards. Those two values up here, they multiplied together and gave me my last value. So what I'm looking at, when I'm determining these two things, I want to look at my constant term, so 12. So I want to make a list of everything I can think of that multiplies together to make 12. So there's 1 and 12, 2 and 6, and 3 and 4. So this, as I mentioned before, this method is called the guess and check method. And here is why. What I'm going to do now is, I don't know, theoretically, remember, imagine I don't have all this stuff up here. I don't know which pair I am supposed to use. So what I'm going to do is I'm going to guess which one I want to use and check to see if it actually works. So let's just guess 1 and 12. So I'm going to put a 1 right here and a 12 right here. And I want to check to see if this actually works. And the way I'm going to check it is by determining my middle value right here. And if we look backwards, this middle value came from two different places. It came from multiplying the inside numbers together. That's where I got this negative 3x from, right? And multiplying the outside numbers together. So what I want to do is I want to multiply these together. This gives me 2x. This gives me 12x. And the question I want to ask myself is, can I add or subtract these from each other and get 5x? Well, if I add them together, I get 14x, and if I subtract them from each other, I get 10x. So this is not the right answer. I've now checked it. I checked. It is not right. So 1 and 12 do not go here. Now, I could have them switched around. So let's try it, see what happens if I switch them around. So let me erase this, erase that, get rid of that. Let's see what happens if I switch them around. So before I had the 1 here, now if I put the 12 here and the 1 here, okay, that gives me 24x and 1x. Can those add or subtract to make 5? No, they can't. They either add to make 25 or subtract to make 23. So that wasn't right. So what I've done now is I have eliminated 1 and 12 as an answer. So let me erase this again. Go back a little bit, and just kind of backtrack a little bit. There we go. I have now eliminated 1 and 12 as a possible answer. Okay. Now I just choose another one. Let's choose 3 and 4. I'm going to put the 3 right here and the 4 right here. We'll check this one to see if it works. So 3 times 2 is 6x. 4 times 1 is 4x. Can they make 5? No, they cannot. They either make 10 or they make 2. So that wasn't right. So we'll back up. We'll try it in the reverse order. We'll put the 4 over here and the 3 over here. So this time the 4 gets multiplied to the 2 and gives me 8x. And the 3 gets multiplied to the 1 and gives me 3x. These can make positive 5x if my 8 is positive and my 3 is negative. Positive 8x minus 3x is 5x. That means I want these guys to be positive. So that means it's a positive sign right here. So I have a positive 4 times a positive 2 gives me positive 8. Positive 1 times a negative 3 will get me negative 3x. And the very last, and so this I believe is my answer. The very last thing I want to check to make sure I have the right answer is I need to verify that I have the right symbol here. So if I multiply positive 4 times a negative 3, do I get negative 12? Yes, I do. So this is my answer. And you will notice that this is the same thing I have up here. They're just in a different order, which is fine for multiplication. You can have them in different orders. So 2x minus 3 times 1x plus 4. So that's how you do the guess and check method. Okay, so here's another example. With any way that I try to factor something, the very first thing I want to check is, are all the terms divisible by the same value? And I want to look at both numbers and letters. So this one's divisible by x, so is this term, but this term is not divisible by x, so I cannot pull out an x. However, they are all divisible by 2. So the first thing I'm going to be doing is I'm going to divide out a 2. So I'm going to pull out a 2, and that leaves me with this divided by 2 is simply x squared. This divided by 2 is 5x, and this divided by 2 is negative 6. Now, that step is not necessarily required. However, if you think about what the first thing we're going to be doing here is factoring this value and factoring this value, okay, I just now came up with smaller numbers to factor, so it makes my list a lot less than it needs to be. So here we go. First thing I want to do after that is I want to write down what my answer looks like. So I know it's going to have 2 sets of parentheses. I know I'm going to have something here, something here, something here, and something here. And since I pulled out a 2 on this problem, I know I'm also going to have that 2 on the outside. So I just kind of carry him down. All right, so to figure out what goes in this slot right here and this slot right here, I look at this value and what multiplies together to get 1x squared. So I'm going to come over here and write a list off all the things I can think of that multiply together to equal 1. And really the only integers that do that are 1 and 1. So I know this has to be a 1x and a 1x. Or if you just want to put x, that's fine. But 1x times 1x is 1x squared. These values have to multiply together to get this term. So I'm going to come over here and I'm going to write 6. I'm going to write down everything I can think of that multiplies together to get 6. 1 and 6 and 2 and 3. Then what I want to do is I want to guess which pair is left to go here. So I am going to choose, let's try 2 and 3. So I'm going to try 2 and 3, and now we check it. I'm going to multiply these two together and I get 2x. I'm going to multiply these two together and get 3x. And my question is, can these add or subtract from each other to make 5? Positive 5. And yeah, they can if they're both positive. And wow, just like that, we think we've got our answer. So this is going to be positive. And this one right here is also going to be positive. So my numbers worked out wonderfully. It got me that middle term that I needed. However, the last thing I always need to check is if I multiply these two numbers together again, do I get this value right here? And a positive 2 times a positive 3 is not negative 6. So while my numbers worked out wonderfully, the signs don't. So actually, that is the wrong answer. And if I even were to switch the 3 and the 2 around, it won't matter since they're both getting multiplied to 1s. So I'd still end up getting a 3 and a 2 down here. It's still not going to work. So I have now eliminated 2 and 3 as an option. So let me backtrack a little bit. Let's get rid of our guess here. Don't want to go too far. There we go. Get rid of my guess. 2 and 3, boom, eliminated. So hopefully it's 1 and 6. So let's try 1 and 6. Multiply these together and I get 1x. Multiply these together and I get 6x. Can they make 5? Yes, if 6 is positive and 1 is negative, they'll make 5x. So this is going to be a negative, this is going to be a positive. Double check, negative 1 times positive 6. It does equal negative 6. So this right here is my answer. And that has been factored. So a couple things to keep in mind. If they are all divisible by something at the very beginning, pull that thing out. And then always make sure to double check your answer to make sure it works. Okay, here's another practice problem. We'll do one more after this, so for a total of 3 practice problems. So first thing I want to look at is there anything that they are all divisible by? 4, 29, and 24, the largest number that goes evenly into all 3 of those is a 1, so I can't pull out a number. However, this has an x, this has an x, and that has an x. This one has 3 of them, 2 of them, and 1 of them. So they all have at least one x. So I can factor out an x. So I'll do that now. Let's see, that leaves me with 4x squared plus 29x minus 24. And now I'm ready to go. So I know my answer is going to look like this with an x out in front. My front 2 numbers have to multiply together to equal 4. So I've got 4. I've got 2 options. I got 1 and 4 and 2 and 2. So unfortunately, I don't know which one to use. All right, so let's come back to that in a second. Let's look at this other number, 24. List all the things that work to make 24. Is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So this is where the guess and check method can get more complicated if I have multiple choices for each one. When I only have one choice for one of them, it's really easy. If I only have one choice for both of them, it's even easier. So we have to kind of guess which ones we want to use. I would recommend anytime you ever have a pair of numbers that are the same thing, start with those, not because there might be the answer, but because it helps me eliminate things a lot faster, and I'll show you why in a second. So that's going to be 2x times 2x. So let's just pick one of these out of our hat. I know I need to try to get up to 29, so I don't want to go too big. Like 24 is going to be too big. 24 times 2 is going to be 48. That's way too big. Let's start with one of these ones in the middle. Let's try 3 and 8. So if I try 3 and 8, multiply those together and I get 6x, multiply those together and I get 16x. 16 and 6 cannot make 29. So I know that this is not going to be the way it worked, my answer. Now, if I tried switching these around, so if I put the 8 over here and the 3 over here, you'll notice it's not going to affect my answer at all because 8 is still getting multiplied to 2, so I still get 16, and 3 is still getting multiplied to 2, so I still get 6. So the nice thing about doing doubles is you don't have to switch the other pair around because you're going to get the same answer. So I've now eliminated 3 and 8 with 2 and 2. Now 3 and 8 might work with 1 and 4, but I have eliminated it with 2 and 2. So now let's try another one. I need a bigger eraser, just a second. Whoops. There we go. Bigger eraser. So let's erase all that. Let's try now 4 and 6 and see if 4 and 6 works. So we've got 4 and 6. 4 times 2 is 8, and 2 times 6 is 12. 8 and 12, not going to work. So I've now eliminated 4 and 6 with 2 and 2 with that pair. So that's gone. Let's try the 2 and 12 really fast. And some of these you can do them in your head when you get pretty good at this. So 2 and 12, that makes 4, that makes 24. Close, I'll make 28, but it won't make 29. So that one's gone. And without even trying, I can look at 1 and 24. So if I had a 1 right here, 1 and 2 will make 2, and 24 and 2 make 48. That one's not going to work. So what I have now done is I have eliminated 2 and 2 as being a possible answer. I know it's not 2 and 2. So now let's get rid of the 2's, and we'll put 1 and 4. So 1x and 4x. Now all of these are back on the table. So let's try, I don't know, let's try 3 and 8. I know it's odd, so I want to have an odd number in there somewhere. So 3 and 8. 3 and 4 make 12. 8 and 1 make 8. 8 and 12 do not make 29. So I know that's not right. Let's try switching them around. So if I put the 8 over here and the 3 over here, 8 and 4 make 32. Ooh. 3 and 1 make 3. 32 and 3 can make 29 if, so these are both x's, if 32 is positive and 3 is negative. So this needs to be positive, this one needs to be negative. I think that's my answer. I will just double check my two numbers here really fast. A positive times a negative is equal to a negative, and so that is my final answer. No need to check anything else because this is the only one that's going to work. And so we're done with that problem. So that one was a little bit more complicated because there was multiple options for both numbers. And that's what makes this method complicated, the more options you have. So let's try one more. Okay, so this is the last kind of problem that we might see. Notice this one only has 2 terms, which is kind of different. The other ones we've been doing had 3 terms. So let's see. The first thing I want to do is I want to take a look at these and see if there's anything that they are divisible by. 6 and 42 are both divisible by 6, so I can pull out a 6. And this is x cubed, this is x squared, so they both have at least 2 x's. So I can pull out a 6 and I can pull out an x squared. Now for this guess and check method, the term with the highest power, we really want it to be positive. So not only am I going to pull out a positive 6, I'm going to pull out a negative 6. That will make my term with the highest power a positive number in the end. So if I pull that out, I am left with just an x, and if I pull a negative 6 out of negative 42, so negative 42 divided by negative 6 is positive 7, and x squared divided by x squared is just 1. This is my answer right here that I get when I pull out negative 6x squared. Now look at what's left. This is not a quadratic. It is a degree 1 polynomial. It is no longer quadratic. Our guess and check method really only works for quadratics. The idea is to factor a quadratic and get down to linear form. This already is in linear form, so we actually have done everything we need to do on this problem. We are done with that. That is it. We have come up with 2 things that multiply together to get this, and both of them are as simplified or as factored as we can possibly get them. So we are done. If this had ended up being a squared left over, I wouldn't be done. I would then have to try to factor this one right here. But since it's a degree 1, we are done.